In July 2025, something arrived in our solar system from interstellar space, only the third object ever confirmed to make that journey. Harvard astronomer Avi Loeb calculated that its trajectory had a 0.2% chance of being natural. SETI aimed its instruments at it, and right now they haven't fully closed the case. So what exactly did we just let pass us by? Let me back up, because to understand why this object is different, genuinely different, not just hype, you need to understand what came before it, and what came before it was already strange enough to shake a few assumptions. In 2017, astronomers detected the first confirmed interstellar object ever observed passing through our solar system. They named it Oumuamua, a Hawaiian word meaning something like first distant messenger. And from the moment it was spotted, it didn't behave the way it should. It was moving too fast. It wasn't shedding the kind of gas or dust you'd expect from a comet. It had an unusual shape, possibly flat, possibly elongated, unlike anything in our own solar system. And here's the thing that lodged itself in the back of a lot of researchers' minds. It was accelerating, speeding up as it moved away from the sun, with no obvious source pushing it. Most scientists landed on a relatively mundane explanation, outgassing of hydrogen perhaps, invisible to our instruments. But Avi Loeb, chair of Harvard's astronomy department, wasn't satisfied with that. He wrote a book. He started a research initiative called the Galileo Project, specifically designed to look for exactly this kind of anomaly, with better instruments, better methodology, less institutional reluctance. And then, in 2019, a second interstellar object showed up, Borisov. This one behaved more like a comet. It was easier to explain. The debate quieted a little. Some people said, see, Oumuamua was just unusual, not impossible, just unusual. Now here's where I want you to hold a question in mind, because we're going to come back to it. If interstellar objects pass through our solar system more often than we thought, why are we only detecting them now? And what exactly determines how closely we look? That brings us to 2025. The object is designated 3I/Atlas. Discovered by the Atlas Survey Telescope Network in July 2025, it was immediately flagged as interstellar, meaning its trajectory, its speed, the math of its path, all confirmed it did not originate inside our solar system. It came from somewhere else. From the direction of the constellation Sagittarius, moving fast, extraordinarily fast by solar system standards. This alone would be remarkable. Third confirmed interstellar object in recorded history. That's already a story. But then the details started coming in. Loeb's team ran the orbital calculations. The trajectory, specifically the angle and speed at which 3I/Atlas entered the solar system, had only a 0.2% probability of being the result of natural gravitational dynamics.
Natural objects pick up speed through gravitational interactions over millions of years. This thing's numbers were off. Not impossible, but statistically unusual in a way that doesn't just quietly go away. And here's the twist layer, the thing we didn't expect when this story first broke. SETI, the search for extraterrestrial intelligence, pointed instruments at 3I/ATLS. They scanned it for radio signals. They were looking for anything structured, any pattern, anything that didn't fit the noise. And the initial reports? Inconclusive. Not nothing. Inconclusive. There's a difference. Inconclusive means the data doesn't tell a clean story either way. Now, I want to be careful here. Inconclusive is not confirmation of anything. Science requires extraordinary evidence for extraordinary claims, and that bar has not been cleared. But inconclusive is also not the same as ruled out. And for an object with a 0.2% natural trajectory probability, traveling at interstellar speeds, passing through our solar system in a window when we barely have the instrumentation to see it, inconclusive feels like a word we should sit with for a while. Ask yourself this: if something genuinely unusual was passing through our neighborhood, what would the data actually look like? Would it look like a clean detection? Or would it look like this? Messy, ambiguous, not quite fitting the expected models, generating quiet disagreement in academic circles while the news cycle moves on. There's another layer to this that I find genuinely unsettling. We almost missed it. The Atlas network caught it relatively late in its approach. By the time coordinated observation efforts ramped up, the window to study it closely was already closing. The Galileo Project, which Loeb specifically designed to not look away from objects like this, did manage to get data. But the infrastructure we'd need to really study an interstellar object, a fast response space probe, pre-positioned instruments, international coordination, doesn't fully exist yet. In other words, even if this object was entirely mundane, even if it turns out to be an unusual rock from another star system and nothing more, we nearly watched it go by without understanding it. That is by itself a strange kind of failure, and it raises the question we started with in a new way. How many have we missed entirely? Here's the most plausible interpretation, and I'll give it to you straight. 3I-ATLS is most likely a comet or asteroid from another stellar system, ejected by gravitational dynamics and making a once-in-a-civilization pass through our neighborhood. The unusual trajectory may reflect the dynamics of its origin system, which operated under different conditions than ours. The SETI inconclusive result may simply mean the instruments weren't ideally positioned or the observation window was too short. That is the most probable answer. But here's what I keep coming back to. Loeb isn't a fringe figure.
He's not a conspiracy theorist. He ran Harvard's astronomy department. He's methodologically careful, even if his conclusions are controversial. And he is not satisfied with probably natural. He's saying the data warrants a closer look than it's getting. The Galileo Project is continuing to analyze the data from 3I Atlas. We don't have final results yet. The case, officially, is open. And somewhere out there, moving away from us at a speed no human-made object could catch, is whatever it actually is. We may never know. That's the honest answer. The window closed, the object is gone, and we are left with numbers that don't quite add up and instruments that weren't quite ready. Whether that's frustrating or terrifying probably depends on what you think is actually out there. I know what I think, but I'd rather hear from you. If this kind of thing keeps you up at night, or if you've had an experience you can't explain, something that sits in that same uncomfortable space between probably nothing and but what if, drop it in the comments. I read every single one. And if you want to keep going down this road together, subscribe. We're only getting started.